Good morning and welcome everyone. Thank you for joining us for today's webinar. Today we are presenting Shaping the Future of BESS and EV Infrastructure.
And now who we are, who is TE, right? So we're close to a $15 billion company according to our fiscal year 21 sales. We're divided into three main business units. Number one being transportation with 9 billion. Transportation has sub-BUs ranging from automotive, ICT, sensors, and application tooling. Worth mentioning is that we have some sort of tooling for most or all of our products. Then we move to industrial, 3.8 billion, ranging from industrial solutions, aerospace, defense and marine, medical, and energy. And finally, communication solutions, 2.1 billion. And we have sub-BUs with appliance, data, and devices. Now, about our revenue, our sales globally, it's pretty much about equal. So we have 4 billion coming from the Americas, 5.5 billion coming from Europe and MEA, and 5.4 billion coming from Asia Pacific. Manufacturing sites, we have 35 manufacturing facilities in the Americas, 46 at EMEA, and 22 in Asia Pacific. And we are in over 140 countries. Now, a little bit about our industrial technology leadership. We're in Fortune, some of the most admired companies in the world, and top 100 global innovator. We have over 50,000 different patents. 617 million have been invested in engineering and R&D. More than 8,000 R&D engineers globally, and approximately 20% of our revenue comes from MPIs or new product introductions. Now, sustainability, considering that it's a trend right now, at TE is no different, and it's something very important part of our strategy moving forward. So we are trying to reduce greenhouse effect intensity by 30% so far, energy use 30% down, and water usage close to 30% as well. We unleash our global talent, and we are some of the best places to work globally, part of the most ethical companies, and our core values about integrity, accountability, teamwork, and innovation. And we take our core values very seriously. Now, funneling a little bit about who we are at TE Industrial. TE Industrial, we're a 1.4 billion revenue business unit, and we're divided into 4 sub-verticals. So we have industrial devices, industrial systems, industrial relays. That's where Jonathan and Brian are gonna be talking about later on, and the electrical. So we're serving over 100,000 different customers globally, and we're playing in a 12 billion global market. Just a little bit, a brief overview about TE Industrial product portfolio. We offer the broadest range of connectivity and sensor technologies, ranging from connectors, relays, terminal blocks, passives, filters, terminals and splices, sensors, identification solutions and labeling, cable assemblies, and custom solutions. And now, at the early beginning, I talk about the AFGs, or the application focused growth. So our AFGs are driven by co-creation. So we want to create something brilliant with you based on the applications. We have ECE, or extraordinary customer support, and then we're trying to helping you grow and along with your customers. We have different AFGs ranging from motions and drives, automation controls, industrial robotics, outdoor LED lighting, warehouse automation, semiconductor machinery equipment, automation sensors, and today we're going to be talking about BESS and EVI, which stands for battery energy storage systems and electric vehicle infrastructure. And then a quick overview on BESS and EVI. Now, landscape. The way that we're looking at this at TE in terms of landscape for BESS and EVI, we're looking at it by on the grid and off the grid, and the power transmission versus power consumption. So on the grid, we're looking at wind power, solar power, and the substations. Off the grid, we're looking at factory and commercial BESS, residential BESS, and obviously the EV infrastructure or the EV chargers ranging from AC charging to DC fast charging. Some of the most interesting and important industry drivers right now, and it has to do with increasing the battery cell capacity, increasing the BESS station voltage, improving power density, and the demand for a shorter design cycle to get to market faster. This is going to help our customers and your customers. TE supports with precise battery system capabilities, compact, reliable connectors designed to optimize efficiency, a more ruggedized battery systems, and a faster development for next generation products. How do we see the future, right, in terms of market trends? Power generation with less disturbance to the power grid, the need for more backup power for the battery energy storage systems, and the debate about the chicken or the egg, right? What comes first? Either we develop EV infrastructure, or do we develop the EVs themselves? So at TE, we think both are coming fast, and we are helping with solutions for both. And TE's role, we're improving power allocation flexibility in power generation, supporting new charging trends, meeting a higher charging requirement, and providing industry-leading connectivity solutions. The energy subsystems. So this is where we're starting to divide BESS versus EVI. On BESS, we're looking at BMS, battery management systems, battery controls, solar inverters, and power conversion systems. EVI, we have AC charging stations. We have level 1 and level 2 here. I'm gonna talk about that a little bit more shorter. And the DC fast charging solutions. And now a quick overview on BESS. The key subsystems for BESS, as we're looking at it, from a power generation and power transmission. Remember, this is on the grid. So we have BESS station for more than a megawatt. And here we are looking at applications like solar inverter, the string solar inverter, power conversion systems, and the battery systems themselves. And now on the power consumption off grid, we are seeing factory commercial BESS, and we are seeing residential BESS, right? And we have similar applications in terms of power conversion systems, battery systems, string solar inverter, and battery systems. Now, talk about central solar inverter, right? TE offers a broad range of different products. Some of the most important in this topic are off-board power resistors, terminal blocks. We have DBL and SNK from an Entrolink product portfolio, and we have main DC contactor, IHV 100, IHV 200, and our 350 series. The string solar inverter, same here. We have a broad range of products to offer, starting from signal relays. We have IM relay, P2 relays, and more. We'll be discussing the relays more general in a few minutes and next slides. We have DC EMI filters. We have board signal connectors. We have passive resistors, AC EMI filters, Ethernet connectors like RJ45. And again, we have a broader offering on power relays like T9S, PCFN, and OJS. Power conversion systems. So remember that all of these are the different applications for BESS, ranging, again, product portfolio, DC contactors, IHV 200, pre-charge resistors, and off-board power resistors, EMI filters, terminal blocks, again, TBL, SNK, and PPI relays. And finally, the battery systems. And the products that we have for this specific application are switches, board hybrid connectors like dynamic series, power connectors, HPC and HDC, so heavy duty connectors from TE, DC contactors, off-board power resistors, NGC connectors, RJ45, and EMI filters. So we have everything ranging from low voltage, we have high voltage connectors, and we have signal connectors and relays to go along with the communication side of the products. And now a quick overview on electric vehicle infrastructure. Again, some of the industry drivers on EV that we're looking at is greener and more sustainable products, energy efficient. This needs to be cost effective and efficient since we're looking at this from a product perspective. Faster charging and holding that charge for a longer driving range of our EVs. Flexibility, it's always a topic. Standardization of our products. And we're supporting high-performance relays contactors, right, in terms of reliability for charging circuit design, compact and miniaturized connectivity, long electrical switching life and high-quality design, broader portfolio of electric products, and focused field application engineering expertise from our FAEs, from our FEs, and account managers that are able to help and support your projects. And now, landscape on EV charging, I started saying that there are certain levels of EV charging. So starting with level 1 and level 2, those are AC charging, normally residential application. And the charging time ranges from a full charge in 12 hours, level 1. Then level 2 comes down to 2 to 3 hours. The user will have to do some necessary applications at their home in order to install a level 2 AC charger. Voltage is ranging from 120 volts on level 1 to 240 on level 2, and current going from 16 amps on level 1 to 80 amps on level 2. Now, level 3 or DC fast, these are the charging piles that we're starting to see as EV charging infrastructure. These are public charging stations or piles, as I said. 80% charge in about 20-30 minutes, and this is where it gets interesting because we're trying and customers are trying to lower that percentage charge in those minutes, coming down as we see a higher speed of charging. Higher means higher amperage and higher voltage. So this is ranging from 200 volts up to 1000 VDC and also 1500, and 50 to 500 amps, and some applications require even higher amperage of 600 amps. Now, a little difference between AC charging, right? Remember, level 1, level 2 versus DC charging, and the product portfolio that we offer, ranging from power relays, DC contactors, board signal connectors, power resistors, switches, filters, terminal blocks. Terminal blocks, we offer a broad range, and electrical solutions, also including identification solutions. And now just a little bit more on the AC charging stations. We have the power relays on the top. We have latching relays as well, power PCB relays. We have identification solutions, as I just mentioned, terminals and splices, terminal blocks, power distribution blocks, DVLs, and we have our dynamic series connectors, ranging from different series depending on your needs, design needs and specifications, power resistors, the filters, EMI filters, board signal connectors, and anti-vandal switches and other type of switches to cover your needs and requirements. DC charging stations products have overlap, and we're seeing some newer products. So we're including the high voltage DC contactors. We have main DC contactors, and we have pre-charge DC contactors. And then again, ranging from power relays, terminal blocks again, and the same offering that can be for DC charging stations as well. And now talking about today and tomorrow, how we're seeing the charging stations right now and the applications that we're looking at. Quick summary, we're looking at AC charging level 1 and level 2. right? So level 1 and level 2 are connected to your typical power outlet in your home. Level 2 needs an additional installation to making it faster, and it's 240 volts. We're looking at DC fast charging stations or level 3, right? This makes charging much faster. Obviously, we're looking at high temperature rates, higher voltage rates, and higher amperage. And we're also working with wireless charging. So this is just this is something new in the market that TE is also focusing and trying to see the latest trends and latest customer technologies that are coming out, and TE wants to support and help drive those new technologies, those new designs. We want to work hand by hand with your design engineers and or all your new projects and designs.
I want to talk a little bit about standards, and of course they dictate a lot, most of what we do in this business. No different for electric vehicle and battery energy storage systems. In the electric vehicle space, a wide variety of standards already available. UL has been coming out with IEC, and the different European standards are coming out with as well. And this slide lists several of those that we understand to be most relevant at this point. They are interrelated in many ways. Some apply to the car, some apply to the chargers themselves. And so just to let you know that we're aware of these, and we're designing to meet the requirements here. These are the standards that don't really apply to the components directly, but our customers, TE's customers, will be taking their products to UL for approvals to these standards. So we have to know what component requirements are embedded within these end product standards as well. So at TE, we've got an array of test laboratories certified by UL and by VDE. So we are able to do a lot of the internal testing that's required. So in many cases, we can do it internally and then submit that data to UL. This speeds up the approval process, and we're glad to have this extra premium service available. Talking a little bit about these three spaces in the EV charging world right now. DC charging, this is the category that's in the news a lot lately. Are we going to have, as Juan mentioned earlier, we're going to have enough charging for folks to travel? They're going to be able to find fast charging in various places across the countryside. So there's a big push, a lot of funding and investments taking place in the fast charging, the DC charging. So this is the so-called level 3 of the 3 levels here in North America. These could come in a variety of different sizes. These DC charging stations. How many charging guns do they have? Some have 1, some have 2 or 4, depending on what's going on at that particular site. When it comes time to design contactors, each charging gun has 2 contactors to break the positive and the negative leg. And at this point, it seems like these are ranging between 750 and 1,000 volt DC systems. We've got products, the IHV contactors that Juan mentioned. We've got some new products coming out. The ECK line of contactors that's going to be suitable for this 1,000 volt range. This DC charging world seems to be divided kind of in 3 groups is the way we see it. There's an 80 kilowatt group, which is of course on the lower end. You need about 150 amp capability there for the main contactor switching. The second group would be, say, around 160 kilowatts. Now we're up to 250 amps. These systems can come with a power distribution unit as well. And then up at the top, we're calling it like a 320 plus kilowatt. This is the really fast charging. We're talking 500, 600 amps. So TE has some products that are adaptable into these different designs. In some cases, like with the PDU, a bidirectional switching is required. We have options there. That second group, the 160 kilowatt, seems to be the most popular and most likely right now. We're focusing on that as well. The next group I want to talk about is over to the right there, the AC charging. As Juan mentioned in an earlier slide, this is broken down into two levels, level 1, level 2. Level 1 is typically that 120 volt device that would maybe go in the trunk of the car. Maybe it comes with the car from the auto manufacturer. 120 volts plug into most places around the country. It's about 16 amps. Takes a long time to charge the car, but it at least gives you some option. And we've got an RTH relay that is suitable for some of the high temperatures that could be seen there. Just two RT relays should be enough for this level 1 charger. It's about 1.9 kilowatts, so not very powerful compared to level 2. Level 2 would be the units that you might have installed in your garage. Could be installed outside of a commercial establishment, outside of an office. This would be level 2. Level 2 kind of has 3 subgroups as we see it right now. On the low end, a 7 kilowatt unit that is, it pulls about 32 amps at 240 volts AC, and our T9V relay is ideal for that. 2 of those should take care of this 7 kilowatt application. Up next from that is like 11 kilowatts. We're up to 48 amps now, and we've just released last year we released a special variation of our T92 relay called T92H. It's a 50 amp relay. Each pole, it's a 2-pole relay, 50 amps. So this relay would cover the 11 kilowatt application. You only need one of those because it's a 2-pole relay. And then up from that is a 19 kilowatt, 19.2 kilowatt applications. Now we're up to 80 amps at 240 volts. So those chargers are out there. They're coming. It's kind of a premium product at this point in the market. We're focusing especially right now on the 2 lower level 2s, the 7 kilowatt, the 11 kilowatt. We've got product available now that will meet those requirements as we're developing product again for the 19 kilowatt as well. These are all the AC chargers I've just spoken of. They're all single phase chargers. Are there any 3-phase? We don't really see that at this point, at least not in the Americas yet. Probably coming, and we're going to be prepared for that as well. But the level 2 takes the majority of share of the U.S. AC charging market, and we think that 32 amp, 48 amp category is going to dominate for the next 3 to 5 years as well. Lastly, on this page, the onboard charger. It's interesting here. This is the of the whole EV ecosystem right now. This is one application that's on the car that we in industrial are very interested in. This is where the industries kind of overlap, and we've got good products in this market, and we're finding a lot of success in the onboard charger. So the companies that make these, then they would go into the vehicle. Now, normally, well, as in all of these chargers, the relay itself doesn't have to switch. The contactor doesn't have to switch the full load. Usually, it's a carry-only design, switching a small load and then carrying the heavy load, and that's the same here for the onboard charger. One interesting thing about the onboard charger that makes it unique, not only is it on the car, but therefore it's usually has very high temperature requirements. It's up to say 105 C, and so that's why our RTH relay has been popular for the 16 amp, the lower end of the power on the OBC designs, which is like 3.3 kilowatts, and then also the T9V relay. It has 105 C degree rating, and for the 32 amp, this is a 6.6 kilowatt. So these are growing. Sometimes it's the onboard charger that is the the restriction on how fast a car can be charged. So these will grow, and we're going to be growing along with that.
As Brian mentioned, with the DC charging, we are developing and have currently our EV contactors. What I'm going to introduce right now is our latest release of DC contactors, the ECK and ECP. These series of contactors are suitable for the 1,000-1,500 volt range. They have not only the high voltage control, but dielectric strength, and the isolation of voltage is also a safety win for us on this product, especially for our customers in this space of the level 3 fast charging. The switching capacity in the ECP can range from 350 amps, 1,500 volts. And for carrying, we have carrying currents upwards of 500 amps on the ECP 350B. The nice design parameters for both ECK and ECP are the bidirectional, so it's non-polarity design for the contacts, which gives your design versatility. We do have a unique hermetically sealed ceramic technology on both the ECK and ECP, which allows for the contactors to be in these harsh environments and still perform under the safety conditions. For the ECK, it's really designed more for the lower kilowatt range from the 150 amp to 250 amp rated current. Both the ECK and ECP have UL standards that we talked about early on in the presentation to go into both the EVSE, DC and AC charging if need be. And then the compliance, which is a good one for this design, is the DC1 utilization. In addition to our relays that we've discussed so far, an area that we've identified within the EVSE design is the controls, electronic controls. So when the onboard charger is ready to accept the charge, it's sending a 9-volt signal to the controls, and then the controls sends typically a 12-volt switch to the contactor or high-powered relay, as you see in the upper left corner of the EVSE vehicle inlet diagram on the right. And so we do have signal relays that are one of the smallest relays on the market for its switching capacity. The IM series relay that's shown here has the capabilities of 60 watt switching power. It's a variety of mounting configurations from through hole to surface mount, as well as the coil options in latching and non-latching, bistable and monostable options. So we do see this on the controls within the EVSE and for the control electronics. So we also have a broad portfolio in relays and contactors that I wanted to point out here for additional controls, specifically in battery energy storage with the cabinet controls and panel plugins. We have our SNR Slim relay. It's one of the slimmest designs on the market right now for its footprint and space within a cabinet control. It features both the relay and the socket. And then we have solid state relays. This is becoming more of a demand for faster switching, longer life, and then our force guided relays, which are considered safety relays. And then in the contactor realm, we do also have definitive purpose contactors. These are AC contactors. as well as our Kilovac brand, with our different business units that Juan mentioned earlier at the beginning of the presentation. We have EV600 and K1K. These contactors can get up to the 600 to 1,000 amp range, and 1,500 volts. So at TE, we have a variety of means of staying in touch, as well as getting our customer support. So if there's more information or you'd like to reach out, we have 24/7 live chat. We have newsletters you can subscribe to, Tech Talks, with our 8,000 plus engineers. They host a variety of tech talks, as well as white papers being produced on the newsletter, of some of our test lab results, investigations into new technologies. That kind of stuff gets published through these media means. And so in closing, why TE? We are focused on empowering the future of electric vehicle charging infrastructure. We are constantly innovating our products to meet the demand of this market. We have a broad portfolio of both AC and DC charging products. That we covered here is just a small portion of the overall portfolio, as Juan broke down the different products that go into it. And then for us, safety is the #1 priority. So with our design intent, we always have safety as the top priority, and that makes the charging circuits more reliable. And then we have dedicated support. We have application engineers across all facets of products, and then we have the product engineers and product managers to support your business needs.